Tripoli. So ওই অনুসারে স্যার মানে which books would be best
I
for this?
suggest some introductory book like একটা বয়েল স্টেটের বই আছে সম্ভবত, দ্যাট ইজ
Right.
গুড। তারপরে হচ্ছে আচ্ছা আমি হচ্ছে গুগল ক্লাসরুমে 2 অথবা 3টে বই হচ্ছে আপলোড করে দিবেন। দিস বুকস আর গুড ফর অ্যাকচুয়ালি দ্য বেসিক্স অ্যাজ ওয়েল অ্যাজ সাম প্র্যাকটিস প্রবলেমস, ঠিক আছে? সো আমি
Sir,
আজই ইনশাল্লাহ, আজ পারবো কিনা, আজকে আমি ট্রাভেল করব, সো সম্ভবত রাতেও পারবো না, কাল অথবা পরশু দিন ইনশাল্লাহ আমি আপলোড করে দিব। কোনো কারণে যদি ভুলে যাই, গুগল ক্লাসরুমে যখন আমি ওই যে ক্লাস ম্যাটেরিয়াল গুলো আপলোড করবো, গত উইকেটটাও করি নাই, লাস্ট ক্লাসেরটাও করি নাই, নিচে জাস্ট একটা কমেন্ট করলে আমি ইনশাল্লাহ বইগুলোর হচ্ছে পিডিএফ কপি, অরিজিনাল পিডিএফ কপি আমি লিংকে হচ্ছে আপলোড করে দিব, সো আপনি ডাউনলোড করে
স্যার নাম দিয়ে দিলেও হবে বিকজ সত্যি কথা বলতে অনলাইন মানে ডিজিটাল কপি
ডাউনলোড করা
পড়তে
যায়,
এত ইয়া
হ্যাঁ।
লাগে স্যার, মানে ওই
না
বইটা
আমি
পড়ে
লিখে দিব নি, তার মধ্যে যে এটা, আর টু বি অনেস্ট হচ্ছে ওই ফিজিক্যাল বইয়ের এখনো বিকল্প নেই। লাইক
এটাই স্যার,
যদি ভালো
এটাই
করে আপনি
মানে
মার্ক করতে পারেন, আপনি নোট করতে পারেন, আপনি নিজের লাইক
মানে একটা
রাইটিং লিখতে
তৃপ্তি
পারেন।
পাওয়া যায় স্যার এই ফিজিক্যাল বইগুলো পড়ে, যেটা মানে ডিজিটাল ইয়াতে পাওয়া যায়। প্লিজ নামটা
দ্যাট ইজ
দিয়ে দিয়েন স্যার।
দ্যাট ইজ ভেরি ট্রু। সো আপনাদের সবারই হচ্ছে মনে হয় সেম প্রজেক্ট না এই 200 এ, মানে ইভেন যদি অন্য সেকশনেরও হন, মানে আমার সাথে ক্লাস না করলেও সবার প্রজেক্ট মনে হয় সেম না, জাস্ট ভ্যালুস গুলো হচ্ছে ডিফারেন্ট।
জি স্যার।
হুম, এতটুকু বলতে পারি যে সার্কিট হচ্ছে খুবই ইজি, যদি জাস্ট সার্কিটটা বোঝেন, কানেকশনটা বোঝেন, মানে কি করতে হবে, সিরিজে লাগাইতে হবে না প্যারালালে লাগাইতে হবে না, কোনটা সিরিজে কোনটা প্যারালালে থাকবে, ওটা যদি বোঝেন তাহলে ইট শুড বি ফাইন, ঠিক আছে? এবং আপনাদের ইজি করে দেওয়া আছে, আহ, সম্ভবত খুবই ইজি করে দেওয়া আছে, এবং সবগুলো রেজাল্টস আই হ্যাভ ভেরিফাইড বাই পার্সন, সো ইট উইল ওয়ার্ক, ইনশাআল্লাহ ইট উইল ওয়ার্ক, ঠিক আছে? এবং কোনো জাস্ট চেষ্টা করেন আপনারা, ইনশাল্লাহ ইনশাল্লাহ পারবেন। আর আপনাদের ডেডলাইন কবে এটার? 20 তারিখ?
20 তারিখ স্যার, জি।
20 তারিখ, so you'll get 1 more week so to submit everything, or just showing the simulation results. What was the instruction given by the other teachers? Shabna madam is there, or probably Saba madam is there. What did they actually say?
স্যার
So
এটা
this is the last thing, right? We have taken the assessment for
জি
the
স্যার।
lab, so that should be the last part. Yeah, try to actually do it very well, because it's a group project, but that will carry around 25 to 30% marks, if I'm not wrong.
স্যার একটা মানে জিজ্ঞাসাই করে ফেলছি, মনে করেন
Sure.
যে আমাদের এক্সপেরিমেন্ট গুলো ভালোই গিয়েছে রিলেটিভলি, মানে ইনস্ট্রাকশন ফলো করেছি, আর আপনি যেভাবে বলেছেন অ্যাজ লং এজ মানে নলেজ অ্যাপ্লাই করা দেখা হয়েছে, মানে মার্ক দেওয়া হবে আই গেস। মানে প্রিভিয়াসটা কি জানি ছিল, এটা এই অ্যাসেসমেন্ট যেটা ছিল আই গেস, ওটা অত
কি
ভালো
অবস্থা এটার?
এমসিকিউ
আচ্ছা, এটা নিয়ে তো কথাই হইলো না আপনাদের।
স্যার।
20204 এর যে এমসিকিউ, এটা কি আউট অফ কনটেক্সট ছিল না কি
জি
ছিল?
স্যার, এটা অ্যাকচুয়ালি আউট অফ কনটেক্সট, বিকজ আমরা এক্সপেক্ট করতেছিলাম যে মানে
আউট অফ
সেটা যা আছে তা থেকে আসবে।
স্যার আউট অফ কনটেক্সট না, বাট আউট অফ সিলেবাস, মানে আমাদের বলা যদি বলা হতো যে
আমার সাথে যারা ল্যাব করেছেন, কোয়ালিটি ফ্যাক্টর অথবা এগুলোর ফর্মুলাগুলো কি দেখেন নাই?
কোয়ালিটি ফ্যাক্টরের একটা ফর্মুলা ছিল,
একটাই ফর্মুলা এক্স্যাক্টলি স্যার,
যে
রাইট রাইট,
যে if not divided by boil the bandwidth এর যে
জি
ফর্মুলা,
স্যার, দ্যাট ইজ
আর একটা ফর্মুলা ছিল ওমেগা নট এল বাই আর অথবা আর
এটা
বাই
আমি
এল,
রিসেন্টলি ফিগার আউট করেছি স্যার, এটা কিন্তু কোথাও দেখিনি।
বাট আমার সাথে ল্যাব করলে তো এটা হচ্ছে আমি ক্লাসে পড়ানোর কথা।
স্যার আপনার সাথে ল্যাব হয়নি স্যার,
আমাদের ল্যাব হয় না,
শেষের দিকে হয়েছে স্যার একেবারে।
কয়টা কোশ্চেনে এরকম হয়েছে, আমি তাহলে এটা হচ্ছে আপনাদের যে বাকি দুজন টিচার আছে তাদের সাথে আমি দরকার হলে আমি কথা বলে নিব, যদি অ্যাকচুয়ালি ইয়ার বাইরে হয় 3-4টা
হতে পারে স্যার।
ঠিক আছে, আমি কথা বলে নিব, যদি সবারই এই ধরনের প্রবলেম হয় তাহলে I will request them so that they will consider the whatever the maximum mark will be like obtained by any one of you, will actually convert it to 100%, and then will scale up every actually other marks. So I will actually recommend that one, but that is not like assured, because there are other teachers, they have to actually agree as well.
স্যার কারণ এক্সপেকটেশনটা ছিল যে আমরা
আপনার পরীক্ষার মধ্যে কেন বলেন নাই? মানে
পরীক্ষার মধ্যে তো মানে মিস একটু স্ট্রিক্ট ছিল, মানে বলার ওই সাহসটা ছিল না আসলে, এটাই কথা ছিল।
সো আপনারা জাস্ট খালি ল্যাব শিটটা পড়েছেন একটু কি?
এইটাই মানে স্যার, এটাই তো এক্সপেকটেশন ছিল, অ্যাটলিস্ট ল্যাবের যদি অ্যাসেসমেন্ট হয়, ল্যাব শিটটা পড়ে এসে বি
That is not
ফ্যামিলিয়ার
always true. Like lab sheet
যদি
is
বলা
just
হতো,
for, you know.
যদি
বলা
বলা
হতো
হতো
যে
তাইলেও
যে
মানে
রেজোনেন্সটা
বাইরে
পড়ে
পড়তাম
আসো,
স্যার।
মানে
জি
বয়েস্টারের বইয়ের যে শেষে রেজোনেন্স চ্যাপ্টার আছে এটা
Actually,
পড়ে আসতাম।
then this is our mistake. If we had actually just like uh, pointed out like you need to read from some reference book regarding, you know, the series resonance things or the high pass filter or the low pass filter, so you'd have actually better idea, right? Okay,
জি
from the next time, inshallah, that will be there.
স্যার।
So
একটা
আমি ইনশাআল্লাহ কথা বলবো, আপনাদের এটা নিয়ে টেনশন করেন না, ঠিক আছে?
স্যার একটা ছোট জিনিস মেনশন করি
বলেন।
স্যার, মানে
নিশ্চয়ই।
দ্য টিচার হু ওয়াজ বিফোর আস, উনি মানে এটা একটু মানে পার্সোনাল মতামত দিয়ে উনি পড়াতো, বাট এক্সট্রা কি পড়লে আগায় থাকা যাবে বা কিসের থেকে কি করা যাবে ওটা দিত না। আপনি একটু পরে এসেছেন আমাদের ক্লাস করার, যাতে সেকশন 2 এর জন্য অ্যাটলিস্ট আপনি হেল্প দেন যে আচ্ছা তোমার এটা পড়া উচিত বা এটা করবা, বা ওই মানে ওইটা আপনি দেন বলে উই আর হিয়ার এখন। আগে যে ওই ফাউন্ডেশনটা থাকার কথা ওটা নাই স্যার, এটাই মানে আনফরচুনেট ব্যাপারটা, যে কোত্থেকে কি পড়বো এটা আমার মানে খুবই লেট রিয়েলাইজ
Okay.
করা হচ্ছে, এটাই আর কিছু না।
Right. I do understand your concern. You know, inshallah, from the next time, we'll be more careful and more
Thank you very much, sir.
like illustrative. All right. So today we'll actually start our session. Probably, yeah. Well, sharing my screen. So probably in the last week we had been talking about, you know, the Thevenin and Norton equivalent circuit, right? So we had actually discussed how to calculate the Thevenin voltage as well as actually the Thevenin impedance as well as Norton current or the parallel current or something like this. Did we, you know, solve this math the last week, or did we actually discuss this math, you know, last week? We had discussed, right? I'm not wrong. Do you recall? Probably not. Somehow I didn't save the annotated file. Yes, so probably I had done. So today we'll be actually, just give me a second. Sorry for the interruption. So the last week we had solved, you know, some actually maths. So today we'll try to solve this math, but by hand. I have got an idea because I have a phone where I can write. So I logged in actually from the phone too. So I'm not sure, can I actually share my screen from actually phone so that I can write there. So if we have a circuit like this, let's say we are going to solve this sort of circuit, and you're asked to actually calculate what is the Thevenin or Norton, it doesn't matter, or Norton actually equivalent circuit for this like this circuit, but the circuits are between actually A and B nodes. That means whatever are there between actually A and B nodes will be converted into a single source with a single resistance, impedance. But that configuration could be in series if we are going for actually Thevenin circuit, means a voltage source and the series impedance, or a current source along with a parallel actually impedance. So that is the actually main concept. Now the question, so even if you are asked to actually solve the Norton or Thevenin, you are free to choose any method. Like you can choose to find the Thevenin circuit first, then just use the source transformation to get, you know, Norton actually circuit, or vice versa. Means you can get actually the Norton circuit first, then use the source transformation to get, you know, the equivalent actually Thevenin circuit. So the last week, since we had solved in Thevenin method first and then actually converted it to equivalent Norton circuit. So here we may actually start with solving for the Norton circuit and then we'll convert it to actually Thevenin equivalent circuit. But there is no harm if you go for the Thevenin circuit first, you'll end up with the same results. So before I actually solve, I want to actually discuss like how do we actually solve this thing. So first thing first, what we will do, we'll convert few things, like we'll convert this one as a single impedance. Sorry. I have to like control set. Is done. So that 2 ohm and that 4 ohm actually capacitor, these are in series. So we can convert that resistor and that capacitor as a single impedance. Similarly, we can do these two as this a combination or something. But since A and B nodes are actually added here, so this one is the load, that XC2 is the load. So we'll actually discuss this thing whenever we want to calculate that Thevenin voltage or the Norton current. So if you remember, the notation of finding actually Thevenin voltage means the open circuit voltage means whatever two reference nodes are given, we'll actually left it open and then we'll calculate the voltage difference between these two. Or what we can do, we can calculate the short circuit current, means I will make it short and then we'll calculate the current here. So in order to do so, I'll stop sharing here, start sharing from my other screen. It's the stop sharing button. I think I have this stopped. So what I wanted to do, I'll start sharing here. Is my mobile phone visible here? No, or not? It's visible, right?
Visible.
Sorry, it is, sir.
Yeah. Thank you so much. Thank you so much. Yeah. If you can't see actually, yeah, let me know. So now I can draw actually, at least. I can draw. Okay, that's good. So if you check here, we had a circuit. And we'll convert this actually as a single impedance. So that is Z1, let's say. That is Z something, some Z. And then the resistor, that is also let's just leave it there. So so that is nothing but the resistor. And then we have two branch. One inductor is here, and then something like this. This is A, and this is B. So now we'll try to solve this one with Norton theory first. Means so we'll get the short circuit current, and then equivalently we can calculate the Thevenin circuit again. So it's up to you. I will actually discuss both how to actually solve this one, because both are acceptable. So this is the circuit. So now my target is to solve using actually Norton circuit. So what I have to do, I need to replace this actually two nodes with a short circuit. So if I replace this one with a short circuit, so how would it actually look like? If I replace it with short circuit, the next term would be, I think this is not good. Some bright color should be better. So this is the current source with that actually impedance, Now, what is the combination of zero? This is a like short circuit. So whatever in the parallel branch, will it have any effect? Because that zero is parallel with some value here, and this is 5 ohm. So what is the combination of these two? If I take the parallel of these two, what would be the value? 0 times 5 divided by 0 plus 5 equal to 0, right? So there will be nothing. So I have a resistor, and then this is the shorts, like whatever things we have. Let's say this is A and B points, and then it is connected here. So my target is to calculate what is the current passing through here. That is ISC, or the short circuit current. That short circuit current is nothing but the Norton current. By definition, this is called the Norton current. So if I do so, how do I actually solve this one? We know this Z1 value, we know this R, we know this I. We can apply the current division rule. This is one of the actually way. Otherwise, you just actually apply a node analysis here. Which one should I actually go for?
So current division rule.
Division rule. Give me a second just. So current division rule, if I apply the current division rule, I want to calculate the current through this. Let's say I replace this one with the impedance Z2. So Z2 is nothing but the R. So what does actually current division rule suggest? That ISC, or the current passing through the Z2 resistor, impedance, is nothing but the given by this summation of all the impedances. Means since this and this are in parallel, do you understand why can we actually use current division rule? Voltage division rule can be applicable in a series circuit, and current division rule can be actually applicable in a parallel circuit. So since Z1 and Z2 are in parallel, so we can actually apply current division rule, and the current division rule says this is Z1 plus Z2, means the summation of all. And if I want to calculate the current passing through Z2, then we'll write actually Z1 here times the total current. Okay, if you are not actually comfortable with this, you don't need to do that. So you know the value of Z1 and Z2, so you actually get to know ISC. Now if you don't want to do that, how could you actually solve? Well, it's very simple. Let's say this is a node, so apply actually this alternative way. Can you actually see my handwriting, or is too tiny? Lou?
It's visible.
It's visible. At least. Thank you so much. At least I can write. So alternatively, actually, if I apply the KCL here, KCL at node A, how would I write? I current is entering, so I current is entering, so minus I. Then we would write VA, so that Z1 is connected between VA and 0, so VA minus 0 divided by Z1, plus A is connected to ground by another impedance is Z2, so VA minus 0 divided by Z2 equal to 0, right? Do you understand this? Hello?
Yes, sir.
Is my yeah, if this is correct, so what I can do, I can solve VA, right? From here, can I solve VA? So if I can solve VA, because we know the value of I, we know value of Z1, we know the value of Z2, so VA we can easily calculate. So once you get to know VA, that ISC is nothing. ISC is the current passing through Z2. So Z2 is connected between A node and 0 nodes. So we'll write VA minus 0 divided by Z2. So once you get to know VA and Z2 value, we already know, then I can calculate ISC. So it's up to you. Even you can apply actually the loop analysis. So there is no hard and fast rules. So this is one of the things. So now you have calculated the Norton current, that ISC is nothing but the I Norton, the Norton current, means the short circuit current. Now I have to calculate what is the impedance, what is the equivalent impedance, that is called Z Thevenin. Since Z Thevenin is Z Norton, so I will calculate the Thevenin circuit. So what is the circuit? What was the circuit? If you check here, so we'll look from that AB nodes. So just try to do like this. Let me actually redraw the circuit once again. So we have that actually one impedance Z1, and there is a resistor, and then inductor, and there is the two nodes A and B, and this is connected here, right? So since that was load, that capacitor was the load, so we'll replace that thing, so we don't need this. We don't need this anymore. So this is two nodes A and B, and we will look actually impedance from here. So now, can anybody tell me, will we take that 5 ohm, or we'll actually discard this thing? Will we discard this thing? Like, does that 5 ohm has value? The answer is yes, it has value. But if we want to calculate the Z Thevenin or the Z Norton, all the the independent source will be deactivated. What does it mean? It means this current source will be replaced by a short circuit or open circuit? What is the idea?
Open circuit.
Open circuit.
Perfect. So let's say this is replaced by Z3. So if this is replaced by an open circuit, I have to change the size of this. Okay. So if this is an open circuit, so basically this is like this. So that Z1 and Z2 are in series. I cannot change A and B nodes. So this is my whole target. So if I redraw the simplified things, that Z1 and Z2 will be replaced by, let's say, Z4 equal to Z1 plus Z2. So along with nothing but a Z3, right? Now Z3 is connected between A and B. So A and B, and this is like this. Now my target is to calculate what is the impedance between ZAB or Z Thevenin or whatever. Now if you look this carefully, that Z3 is connected between A and B nodes. How about Z4? Z4 is also connected between A and B node. Is it correct? Do you understand this part?
Yes, sir.
Now what does it mean? Z4 and Z3 are in series or parallel? If they are connected between the same nodes, same two nodes, what does it mean?
Series, sir.
Oh, really? Okay, let me actually clarify this one. Check here.
Sorry, sir. Parallel hobe, sir.
Okay, A, B, and C. We can say this is and this R1 and R2 in series because only one node is like common, right? The other nodes are not common, and there is no other connection here. But if they are connected like this, what do we say? They are in parallel, right? Why? Why are they actually parallel? Because they are connected between the same two nodes. Means R1 is connected between A and B nodes. R2 is also connected between A and B nodes. That's why actually R1 and R2 are in parallel. Similarly, if I redraw a circuit like this, and then I have a resistor and connected between this, that means still R1, R2, and R3 are in parallel because R3 is still connecting between actually A and B nodes. Is it clear? Hello?
Yes, sir.
Yes,
That makes
sir.
sense.
Now I'm actually repeating the question once again. That Z3 is connected between the A and B nodes because we cannot change A and B nodes. That is our reference node. And Z4 is also connected between actually A and B nodes. What can we actually conclude? That
Then they're in
Z3
parallel.
perfect. So ZAB equal to Z Thevenin. You can write down Z Norton, no problem. Z4 parallel, Z3. So all we have to do is to calculate this one, nothing else. So now, once you get to know this one, so Norton equivalent circuit says it will be replaced by a current source. This is the current source, and there will be an impedance. This is Z Thevenin, and then the reference to points. That reference to points are A and B. So I Norton or ISC, the short circuit current, and this is nothing but the Z Thevenin or Z Norton. So whatever we say. So now, if you are asked to calculate the Thevenin equivalent circuit, how do you solve that? All we have to do is to use a simple source transformation. So what is source transformation of this? A current source along with a parallel impedance can be converted into a voltage source, means that arrow sign, that means the arrow sign plus, this is negative. So this is negative, and with the same impedance, so this is Z Thevenin, but this V Thevenin is nothing but V equal to current times impedance. So current is ISC times actually Z Thevenin. Is it clear here? Is it
Yes,
clear
sir.
here?
Yes, sir.
So we can actually get, now here we have solved the Norton circuit first, and then we got the Thevenin circuit first. What if somebody says, oh, I would like to solve the Thevenin circuit first, and then we'll get the Norton circuit second? The answer is very simple. It's not actually solved in the PDF file. So I'm giving you the hint. You can actually give a try at home. So first we want to solve the Thevenin first. So this is our target. So what was this actually circuit? If I redraw the circuit, it is like this. So it was like this. So now what Thevenin circuit says, the VThevenin is nothing but the open circuit voltage, right? So I will leave this to node as the open. So previously we wanted to calculate the current, the short circuit current, so we made it actually short. So now we left it open. So our target is to calculate what is the voltage between A and B node. So basically this node is also A, right? And this node is also B, right? Is it true? Hello?
Yes, sir.
Yes.
Yes, perfect. If this one is the case, we can apply current division rule. We can use loop equation. The easiest one, we can use the source transformation here. It's up to you. Don't follow me. Okay. You can use actually loop equation, or you can use actually KCL, and you'll get the same answer. So for me, let's try for the source transformation here. Can I replace this one with a voltage source and the impedance itself here? Means this part is here. Can you do so?
Yes, sir.
Can you do so? That voltage source is nothing but the current source times that impedance, and that impedance is here, and then that resistors are here, and the inductor here, and this point is A, this point is B. So how do you calculate the voltage here? Can you calculate the current here? Let's say that
KVL.
current. Yeah, current equal to this voltage. Let's say we don't know this value Vx. This is Z1. This is Z2. This is, let's say, Z3. So what we will say, Vx divided by Z1 plus Z2 plus Z3, right? What is Vx actually? Vx equal to that current. So that current is I times Z1, right? This is Z1. And this is I, then the Vx equal to nothing but the current times Z1. So what is VAB? So VAB, that is equal to VThevenin equal to current times Z3. So this I is, that's I1. So I1 times actually Z3. Do you understand this thing? Hello?
Yes, sir.
Yep.
And you will get the same answer. So now we had already discussed how to get Z-Thevenin. So we are not actually discussing this. So we'll draw the Thevenin equivalent circuit first. So this is VThevenin, then along with Z-Thevenin, and then A and B nodes. A and B nodes. So this is plus, this is minus. This is Thevenin equivalent circuit, Thevenin circuit. And now you can use the source transformation to get the Norton equivalent circuit. So in both cases, you will get the same answer. So whatever you find it actually convenient, you should actually go for that. Do you understand? Hello?
Yes, sir.
Is it clear? Is it clear?
Yes.
All right. Now I will stop sharing here so that I can show you the original workout, because the calculations are not here. So I'll stop sharing for a moment so that I can actually start sharing from here. Let's check, how did we solve, earlier. So this is the total workout. And so we are asked to calculate the Norton and Thevenin circuit, equivalent circuit. We had chosen to calculate the Norton current or the short circuit current first. So we had calculated short circuit current. The workouts are given here. So we'll check this, and then we'll write down the actually Thevenin equivalent circuit from the source transformation, simple actually source transformation. So there is another thing we want to discuss, like the maximum power transfer theorem actually. If you recall from your DC circuit course or EEE 101 probably course, so in that course you have learned in a Thevenin circuit, when I am talking about DC circuit, there are only resistor actually exist. So in Thevenin circuit, the maximum power transfer to load only when the magnitude only when the value of load resistance and the Thevenin resistance are equal. So that was the very concept. Now we want to extend that concept in AC circuit. I will show you, the details actually derivation in my mobile phone. So, but before that, I want to actually just discuss, how does it actually work. So, the maximum power transfer will occur in AC circuit when the Thevenin equivalence impedance is equal to load impedance, because it's a AC circuit, so it's a complex number, resistance and then capacitor, some or inductor, some things will be there. So these two will be equal, but the complex conjugate, what does it mean? The magnitude will be same, but the phase will be just opposite. Means if the Thevenin impedance are having a phase of 30 degree, then the load impedance has to have the phase angle of negative 30 degrees, so that these two will cancel out. I will discuss in details. So only then we'll get the maximum power like delivered in our circuit. So there are some formulas. There are actually some formulas. We'll actually discuss this formula in details. So I will stop sharing here so that I can write. Once again, give me a second. So is my screen visible once again?
Yes.
Perfect. Thank you so much. So we have been actually solving this, right? So now our target is to check what is called maximum power transformation. Maximum power transfer. So what does it mean? So we had actually discussed previously that Thevenin circuit, let's say this is our Thevenin circuit. So this is V Thevenin and in impedance is Z Thevenin. And this is between actually two reference points A and B. So basically these two a voltage source along with Z Thevenin, it could be a combination of, it may actually come from thousands of actually voltage source, current source and impedances, but these parameters do not change, or this component actually do not change. Which is changing is nothing but these 2 points where we used to connect load. So what does it mean? We can connect a mobile phone like Nokia mobile phone or the Sony Ericsson phone or something to characterize how much current are passing through that, or what is the power consumed by that circuit or something like this. These are just for analogy. So this is called ZL. So if you remember from your DC circuit course, whenever you have done such Thevenin circuit or Norton circuit, and we are asked to calculate the maximum power transfer, in that case you had said, whenever R Thevenin is equivalent to R load, we'll get the maximum power transfer delivered to the load. So since we are dealing with now the AC circuit, the scenario is a bit different. So how would we actually solve this thing? So the concept is that, let's say Z Thevenin, the condition is Z Thevenin has to be complex conjugate of L. This is called complex conjugate. So what does it mean actually? My target is to remove since Z Thevenin and ZL are in series. So if I use the complex conjugate term, means the imaginary part of this and this will always cancel out. Means I'm giving you an idea. Let's say Z Thevenin is 2 plus 3J. So it's a complex number, means there is a resistor term and there is an equivalent inductance actually term or something. So in that circuit, the maximum power will transfer only when that load impedance is this. The load impedance is this. So complex conjugate means that J will replace by minus J or vice versa. wherever you will get that, the imaginary number j, you will replace it with actually negative z. So why would you do so? If we do so, then what is the total impedance here? Z Thevenin plus ZL, right? Because these are in series. So if I do so, then you'll see that that complex part will cancel out, and all you have is 2 plus 2 equal to 4, right? So it's a real number. My target is to actually convert it into real number. So in general, if we write down Z Thevenin equal to R Thevenin, means the Thevenin part plus let's say JX Thevenin, then the condition says that load actually impedance has to be the complex conjugate, means the real part will never change. Only thing will change its sign of the imaginary part. So imaginary part would be JX Thevenin. Do you agree with this?
Yes.
All right. So what is Z equivalent? Z equivalent means the total impedance in this circuit. What is Z equivalent? Z Thevenin plus ZL, right?
Yes.
Z Thevenin plus ZL. So what is that value? That imaginary part will cancel out, R Thevenin. So now what is the power right now? So maximum power says maximum power. So before actually maximum power, calculate the current in that circuit. In that circuit, what is the current? V Thevenin divided by Z Thevenin plus ZL, right?
Yes.
What is the current? It's a series circuit. This is the circuit. This is the circuit. This is V Thevenin, this is Z Thevenin, and this is ZL. So we can write down V Thevenin divided by Z Thevenin plus ZL. Can we write down this? So if I
Yes.
put the value of Z Thevenin and ZL at the maximum power transfer condition, it would be simple V Thevenin divided by 2 R Thevenin, because the complex part will cancel out, right? If this is canceling out, what is the power? What is the maximum power? Maximum power where? Maximum power delivered to the load. Like we want to get the maximum power at the load. So if we'll write down the maximum power equal to I square, like I square times. Now, will I write down ZL or will I write down ZL, or I will write down R Thevenin? Which one is correct? Can anybody tell me? Hello?
Sir, R Thevenin.
Yes, perfect. Because when I say the power, this is nothing but called real power. So when I say real power will be dissipated in only resistor. But in the inductor or in the capacitor, the reactive power will be actually dissipated. So for that case, we'll be writing actually only R Thevenin. So what is the I square value? So V Thevenin square divided by 4 R Thevenin square times R Thevenin. I have just replaced the value of I. So we'll get V Thevenin square divided by 4 R Thevenin. Now, if you remember correctly, this formula is exactly same as the formula from the DC circuit maximum power transfer. If you recall, so it means in AC circuit the maximum power transfer will be equal to the maximum power transfer can be possible in a DC circuit, because the whole circuit will behave like as a resistive circuit. Can we say it means we are having a series resonance? What does series resonance says? আমি যদিও পড়াইনি আপনাদের series resonance so far in the theory class, but in the lab session we had actually studied the series resonance circuit, right? Do you remember series resonance?
RLC.
Okay, whatever, but what was that condition? That XL will be XC, right? Means
Yes, sir. Excel equal.
Means the reactive part will go to 0. So means it will have only the resistive part. So it means this sort of circuit at maximum power transfer, theorem says like we'll get the maximum power transfer only when the reactive part will be actually 0. So the whole thing will behave as a resistive circuit. So can anybody tell me what is the power factor at purely resistive circuit? Do you understand the power factor?
0.
Yes, sir.
Yes, perfect.
One.
So power factor
One
says, yes, power factor is 1. The phase angle is 0 because in the resistive circuit, in a purely resistive circuit, the voltage and current are in phase. What does it mean? If I plot voltage, let's say this is voltage, and if I plot current, then we'll see only the magnitude will change. Mostly magnitude will change, but the phase will be the same. So this is current. So the phase difference is phase difference equals 0. No phase difference are here. So if phase difference is equal to 0, then the power factor will be cos 0 degrees. So cos 0 means actually 1. Do you agree with me? Hello?
Yes, sir. Sir,
All
are we
right.
considering conjugates because we are not taking any complex reactants?
Look, yes. So we are trying to actually find out at which condition we'll get the maximum power transfer to the load. It doesn't mean that always we'll have the complex conjugate of the Z Thevenins. If I have other values, for our case, we had to use, what is the value? Let's say 2 plus 3Z. So if the load actually impedance is not 2 minus 3Z, still there will be some power transfer, but that is not the maximum power. Means in our exam, you can get maximum 100 marks, right? So, but if your exam are not up to your best, so you'll get some mark, but that would be actually less than 100 marks. So similarly, if ZL is not equal to 2 minus 3Z, because only this condition, that ZL is complex conjugate of actually the Thevenin equivalent impedance. Still, there will be some power transfer, means the real power transfer, but that real power transfer would be less than this value. This is the maximum power, V Thevenin squared divided by 4 R Thevenin. So that value would be less than this. Is it clear now?
Yes, sir. মানে আমরা আর কি যত কমপ্লেক্স পার্ট আছে সেগুলো বাদ দিয়ে দিচ্ছি।
Yes.
আর
যদি ZL এবং Z Thevenin are not equal and complex conjugate না হয়, তাহলে যেটা হবে ওই ভোল্টেজ এবং কারেন্টের মধ্যে একটা ফেজ ডিফারেন্স থাকবে। যদি ফেজ ডিফারেন্স থাকে তাহলে পাওয়ার ফ্যাক্টরটা 1 হবে না, আর পাওয়ার ফ্যাক্টর যদি 1 না হয় তাহলে রিয়েল পাওয়ার কমে যাবে। কারণ রিয়েল পাওয়ারের আরেকটা ফর্মুলা ইন এসি সার্কিট ইকুয়াল টু VI cos θ। সো V হচ্ছে ভোল্টেজ, আর দেন I হচ্ছে কারেন্ট যার অ্যাক্রসে আপনি পাওয়ার বের করতে চান, and times cos θ, the difference between the phase difference between voltage and current. So the maximum value of cos θ equal to 1. So এখন যদি cos θ ভ্যালু 1 এর থেকে কম হয়, মানে 0 ডিগ্রি না হয়, তখন টোটাল ভ্যালু কমে যাবে। ঠিক আছে, এবার দেখা যাক একটা এক্সাম্পল। So now let's say we have a voltage source and then a bridge connection. We have a bridge connection that is called Z load and a resistor 8 ohm. So let's say these points are marked as A, B, and then C, and then D. Let's say this is 9 ohm, this is 9 ohm as well, this is 9 ohm as well. So if this one is the case, my target is to calculate, this is E equal to 10, 0 degree. So my target is to calculate what is the load impedance, for the maximum power transfer, and also we need to calculate the maximum power transfer to the load. So we need to calculate two things. Like we know what would be the load impedance, like at which load will get the maximum power transfer, and what is that maximum power. So two things. So now we had just actually solved, in order to get the maximum power transfer condition, we need to calculate the Z Thevenin. So Z Thevenin, the reference points are not given. Can anybody actually point out between which two nodes we need to calculate the Thevenin impedance? Because nothing is actually given here.
B and D.
Yes, the answer is correct. How about other students? Did they actually understand?
Yes, sir.
Because although nothing is given, like pointing out A, B, C, D, there are 4 actually nodes that are pointing out. So someone might be actually a bit confused, like between which two nodes we will be calculating actually the Thevenin impedance. But one thing is explicitly written, which is called that load impedance, or the load. So that load, and that actually denotes, this one would be the actually what is it called, the reference point. So my target is to calculate Z Thevenin. So in order to calculate Z Thevenin, what are the how would we actually calculate Z Thevenin? All the independent source will be deactivated, and will actually left these two nodes actually open, right? Like between B and D nodes, everything will be actually open. So if this one is the case, how do you calculate? First, we're going to calculate Z Thevenin. So for the Z Thevenin, how will it be? All right. So this one would be a short circuit. And then this one would be one impedance. This one would be another impedance. This one would be another impedance. Then this one would be another impedance. But this is an open circuit, so my target is to calculate what is the impedance between B and D nodes. So this is my target. Can anybody actually understand this drawing for the Z Thevenin? So what we have done, we have deactivated this voltage source. So deactivated this voltage source means we will replace the voltage source with a short circuit. All we have is that 9 ohm, that this is nothing but an impedance. This is nothing but an impedance. This is nothing but an impedance. This is open because we want to calculate the impedance between these two nodes, and this is also replaced by another actually impedance. Let's say Z1, Z3, and Z3 or something. Let's say ZR, ZY1, Y2, and Y3. So up to you. So now, can anybody tell me how to actually solve this one?
Sir, we can consider the A and B portion in series, and then we can put it in parallel with the 9 ohm. All of them are 9 ohm.
So did you mean A and B portion?
A, B, and C, like the triangle on the left side. Yes.
Are they in
that
series?
Is
Are they in series?
That is actually
delta Y করতে পারি স্যার।
right.
Okay.
That is another.
So no. Yes. Now the confusion, because in exam you have to be actually
parallel আছে না স্যার সব?
No. Both are correct. If someone is saying that this one and this one are in series, right? Because nothing is connected here. But if I use this one, then my B node will be changed, right? That we cannot do. My reference point is B and D, so we cannot change these two nodes. Do you understand?
Yes,
This
sir.
is very tempting. Somebody thinks like, oh, this one and this one are in parallel, then we'll get a single actually impedance, and then that is actually, sorry, this one and this one are in series, we'll get one, and then that is actually parallel with this one, so it would be so easy to actually solve. But your reference point will be actually destroyed, so you cannot do that. I cannot change the B and D nodes. Okay, so this is the sole things. Now, although it's looking a bit complicated, to be honest, this is not. since this is a short circuit, A and D nodes are same, right? Do you understand this?
Yes.
Hello?
Yes.
Okay.
Yes,
So
sir.
let's say this is Z2, this is Z1, and this is Z3. Now you check my target. I cannot change B and D nodes because these are the reference node. So this Z2 is connected between A and C, right? Hello? Z2 impedance is connected between A and C
Yes,
node.
sir.
Yes.
Similarly, ZR is connected between A and C node. Is it true?
Yes.
They are in parallel.
They are in parallel. So what we can draw? We can draw, this is A, this is B, this is Z3 and C. C. So now we had a parallel combination. Parallel combination means, okay, leave it there. Since they are in parallel combination, this is D equal to A point. So that parallel combination is nothing, Z2 parallel ZR. Do you understand this 2 point? What I wanted to say? Is it true? Hello?
Yes, sir.
Okay, we had just drawn, because between C and A nodes, we have two impedances, Z2 and ZR, so these are in parallel. So I have written like this. So now, since this is A, can we write down this is equal to D, because D equal to A, because these two are the short circuit. If this is the short circuit, we can see my target, we cannot change this point and this point. So now we
Sir,
can
could you
write down.
please repeat it? That
Okay, forget about this. No problem.
A
Forget
and
this
C.
one. What is the case? Now,
Sir,
now it's
A
clear,
and
right?
there was
Okay,
another
no problem.
okay.
Look, that
Z2.
Z2 is connected between A and C node. ZR is connected between A and C node. To be honest, there is another one is actually connected
ওকে স্যার
between
বুঝতে
these
পারছি
two.
মানে
So,
আরেকটা
so এই দুটো
ওদিকে
হচ্ছে,
এঁকেছিলেন এই জন্য বুঝি নাই
all right. So these two are parallel. So I have actually replaced this two with actually parallel. So now, what is the value? My target is to calculate B and D. So now you see that this one and this one are in series. Hello? You see this one and this one are in series, because I cannot change only this node and this node. Other nodes we can change. So we can draw a circuit. Similarly, let's put it A. This is B. And now between these two, we'll actually replace with a single impedance, that is Z3 plus, Z whatever. Let's say this is Z4. So Z4. If this is the case, we'll write down this B and this is D. So this is my whole target. I can never change this to reference point. So what is the idea? How about this? That Z1 and let's say this is Z5, that Z1 and Z5 are in parallel, right? So Z13 is nothing but the Z1 parallel Z5. Do you understand this part? Hello?
Yes, sir.
Oh, this is the answer. So other thing, you don't need to do
So
anything
shouldn't we
actual.
can we consider the impedance between B and D?
B and yeah,
D.
yeah, we are calculating impedance between B and D. So B and D, we're not changing anything else.
Sir,
So now, বলেন
জি Z2 এ কি করলেন স্যার মানে what happened to Z2 you omitted it
এখানে দেখেন so Z2 দেখেন A আর C এর মধ্যে কানেক্টেড, আবার ZR কানেক্টেড A and C এর মধ্যে, so by definition these two are in parallel,
right
বুঝেছেন? সো ওই দুটো মিলে কি হবে, একটাতে কনভার্ট হবে না? সো হয় উপরের অংশে রাখবেন না নিচের অংশে রাখবেন, no problem, you'll get the same answer. Now there is another way to solve this one, that is the easiest way, and in our actually workout in the PDF file we have not used this method, but you'll get the same answer. So how could we actually solve this one? You see, this is a delta connection. This is a delta connection. I will use a different color. This is a delta connection, you see. So can I actually replace with a Y connection like this? If you connect, replace it by an Y connection, then you can solve it also, and it would be even easier. So this one is the case. Once you get to know the Z Thevenin, let's say for our circuit, that Z Thevenin is something like this: 0.72 plus 5.46, then Z. So what is the load impedance? Can anybody tell me? At what is the load impedance we need at the maximum power transfer theorem? It has to be the complex conjugate of this one, right? 0.72 minus 5.46 J. So this is one of the answer. Now, in order to calculate the maximum power, we need to you need to know what is the actually Thevenin equivalent voltage. So for the Thevenin equivalent voltage, what is the circuit? So that is the E was given. Let's say this is Z1, then Z2, then Z3, and then Z4. This is Z1. Just write down Z2, Z3, and Z4. And these two nodes will be open, right? Because this is the load. So this is B and D, and it's connected. So how do we actually solve this one? You have two ways of solving. One of the ways, you can use the Y delta connection. So one thing you can do Y delta connection, then if you solve, then it would be a simple things. But I don't suggest that one. So what you can see, how many loops are there? How many loops are here? Can anybody tell me how many loops are here? If I want to use actually KCL,
2 loops.
Or KVL. So just consider the loop. This is as I1. This is as I2. Can we write down in a KVL here? What would be the KVL? So at loop 1, what is the KVL? So this is plus, this is minus. So negative E equal to, with Z1, how many actually currents are there? I1 minus I2. Do you understand? With Z1, 2 currents are passing because it's a shared interface between 2 loops. So the current should be I1 minus I2 because we are at actually loop 1. So I will write I1 first and then I2 in a second. Similarly, it will pass through Z3. So Z3 again, the same thing, I1 minus I2. And with Z4, we have only one, I1 Z4, that equal to 0. Do you understand this thing? Hello? Or I need to explain?
Yeah, I get it.
Okay. If this one is the case, so we can write down the coefficient of anything with I1, and then coefficient of I2 here, and that equal to E. This is equation 1. Similarly, I will write down the equation for loop 2. What would be the loop 2 equation? Can anybody say? Okay, I will write down loop 2 here. So Z2 এর মধ্যে কয়টা কারেন্ট যায়? Hello?
একটা কারেন্ট।
That is I2. Z3 এর মধ্যে কয়টা যায়?
দুইটা।
I2 minus
I1.
I1 minus I2 or I2 minus I1?
I2 minus I1.
সবাই জানেন I2 minus I1. And Z1 এর মধ্যে কয়টা কারেন্ট যায়?
দুইটাই যায়।
I2 minus I1, right? So similarly, that is equal to 0. So if I actually again rearrange the coefficient in such way, so I1 there will be some coefficient, then I2 there will be some coefficient equal to 0 because there's no actual voltage source here. So if I solve equations 1 and 2, solve equation 1 and 2, then we'll get the value of I1, we'll get the value of I2. So now can anybody tell me what would be the value of VB and VD, means what would be the V Thevenin value? means what would be the VThevenin value? VThevenin is nothing but the voltage between B and D node, right? So VThevenin is nothing but the V, B and D. How do you calculate V and D? So between B and D, what is connected? Let's think about Z3 and Z4, right? My target is to start from B and finish at D. I can go from here B to, let's say this is X, B to X, and then come back to D. Or there is another way, B to Y and then come to D. Which one is easier? You'll get the same answer.
B to Y and Y to D.
Okay, so B to Y and Y to D. So from B to Y, which components are there?
Z3.
Z3. So Z3, my target is to write down the equation for impedance, right? Z3 times, what is the current passing through Z3? Look, this direction we are going, right? B to 1. I1 minus I2. Perfect. I1 minus I2. Why didn't we write I2 minus I1? Can anybody actually clarify?
Because we are in the I1 loop.
Or we are going from B to Y. So in this direction is I1 is passing through in this direction, right? B to Y direction. Because I2 is actually passing through like this. So Y to B direction. So plus, now Y to B means Z4. So Z4 times, what is the current passing through Z4? It's nothing but the I1 only. So this is one of the case. This is the different way I'm solving here. But in our PDF file, now I'll stop my sharing here, from here. I think this is stop my sharing. Did I stop my sharing? Yes.
Yes, sir.
Yes, sir.
Perfect. I'll start sharing from my laptop. I believe you can actually see my screen once again. So if this one is the case, check here. This one is the workout here. And how did we actually solve this math? So first target, we had calculated the VThevenin. So for the VThevenin here, this one would be the open circuit. The Z load would be the open circuit. So right now we had seen, if we apply actually the KVL, we can easily solve. Another way of solving is just convert this delta connection into Y connection. So if you convert the delta connection into Y connection, this portion and this portion means the ZY3 and ZR will be in series. You know how to actually go for the delta to Y connection and Y to delta connection, right? We had already learned. So you need to actually remember the formula. So these two are in series. If these two are in series, then we can easily calculate the ZY2 has no value because it's an open circuit for if we want to actually calculate impedance. So this B node and E nodes are equal. So all we have to do is to just apply a simple voltage division rule, nothing else. If I use the voltage division rule, we'll get the actual answer. So what I wanted to say, this one has no impact because this is not a closed loop. So B node and E nodes are equal. So E node equal to B node. So my target is B nodes are here, and this one and this one are in series. So you can actually simplify these two into a single impedance, and then between this one and you need to apply the voltage division rule, right? So this is a series circuit. This will be a series circuit, and you need to apply a voltage division rule. So this is the actual voltage division rule. So maybe you can actually practice at home. It's so simple. And similarly for the Z-Thevenin, they have used actually Y delta connection. Like this is a Y delta connection. So from here, we will just actually replace this voltage source with a short circuit, and we'll calculate the impedance between these two nodes. So you will get the same answer, no matter which way, which method are you using. What is actually maximum power transformer states that load impedance has to be equal to the complex conjugate of the Thevenin actually impedance. So all we have to do is to the negative value, and the maximum power transformer formula is V Thevenin square divided by R Thevenin. Now the question is that V Thevenin square, since V Thevenin is a complex number, will we use the magnitude or the phase or the complex number? The answer is we must use only the magnitude. So if I have something like this, so what is the magnitude? You will convert it into polar format, means you will convert this to r comma theta. So r comma theta, r comma theta. So that r is nothing but that magnitude. So that would be the whole thing. So r squared divided by 4, this r Thevenin, that would be the answer. So that would be the actually maximum power transfer for this circuit. So I believe in your final exam, there will be one question from the maximum power transformer actually like transfer actually theorem. Any questions so far? Hello.
No, sir.
So if you have no questions, so we'll end our session here. Well, thanks for actually joining once again. See you next week. And আপনাদের হচ্ছে কি সিমুলেশন আর ল্যাব হচ্ছে সাবমিট করার কথা না মানে নেক্সট উইকে? হ্যালো
স্যার
প্রজেক্ট সাবমিট করার কথা। প্রজেক্ট আপনারা ট্রাই করেন। আই বিলিভ আপনারা যদি সার্কিটটা জানেন যে সেকেন্ড অর্ডার সার্কিট কিভাবে RLC কম্পোনেন্টে করা যায়, there are many ways of actually doing second order band pass filter using actually operational amplifier and other actually components, but we are not allowed to use this because this is out of our context. So তাহলে খুব ইজিলি বের করতে পারবেন ইনশাআল্লাহ। আর একটু ফর্মুলাগুলো দেখেন বলস্টেডের বই অথবা কোনো রিডিং ম্যাটেরিয়াল থেকে, যে ব্যান্ডউইথের ফর্মুলা কি আছে RLC এর রেসপেক্টে, অথবা কোয়ালিটি ফ্যাক্টরের কি ফর্মুলা আছে RLC এর রেসপেক্টে, তাহলে হচ্ছে খুব ইজিলি হচ্ছে সলভ করতে পারবেন প্রবলেমটা ইনশাআল্লাহ। ঠিক আছে, থ্যাংক ইউ সো মাচ। উইল স্টপ আওয়ার সেশন হিয়ার। হ্যালো।
ওকে স্যার।
Okay, thank you.
Assalamu alaikum.
Walaikum assalam. Stop my recording here.